I'm gonna get everything going here. If you're watching this video after the fact, make sure and look at the description below for all the time codes. I know last week I had some audio issues, so we'll get those hammered out at the start if that's the case today. I don't think it is. And then also, we'll just like say hellos and stuff. So make sure and look in the description for all of that. Sorry for the audio problems last time. I was like super hopeful that we weren't going to have Discord issues, but it looks like it is having issues still, which is unfortunate. Let me just stop all these streams here. It's like I don't need to look at the video coming back to me. Looks like everything's going. Hi, Unexpected Maker. Hi, Paul. Hi, Dishipu. Hi, Moonlight Shaker. Have I been objectified? Yeah, well, apparently no. Apparently it's like half working. Which is good. Is the audio okay, everyone? I was going to just check the thing, but I forgot. We will have a guest as well. Audio is great today. Perfect. Thank you. Hi, Johnny. Thanks, Tinkering Rocks. Audio is good. Hi, Gary. Hi, Mr. Certainly Bruce. Hi, Hugo. Hi, Ken. Jeff says hi. Jeff, you gotta let me know when you're gonna call in. Jeff's gonna join us today, so that's going to be exciting. Let me check Twitch. Oh, you know what? That's one thing I forgot to do is I forgot to pop the Twitch chat out. And I do have mod rights on Twitch now, which is good. During the first hour, please. Okay. Well, Jeff, why don't you just call me and as we can just get that going as we get going. Just video chat me on Discord. And we'll just get you in right now. Open in browser. And then yeah, I'll let you go after the second hour. I don't think my video will work. Let me turn your audio on and pop you out. Can you hear me, Jeff? I can hear you. All right. Can you hear me?
Yeah, I probably need to shut off YouTube or we'll end up with feedback. I'm not sure which of you I'm replying to now, actually.
Yeah, you probably want to mute your YouTube. I will have to do housekeeping here first. Hi, Don. Hi, Alvaro. I'm probably saying that wrong. Hi, Bruce. Hi, Mark. Mr. Certainly is on Twitch as well. I think we gave you mod rights as well, Mr. Certainly, on Twitch. Great. Unexpected Maker can hear you too. And it looks like I was wondering what this empty space on my screen was. It's the spot that I normally put the restream chat. That's why. All right. Perfect. Awesome.
Oh, I'm on camera. I didn't realize.
I'm going to take you off just briefly while I do housekeeping, but then we'll go straight into you. I always have this like period of like getting going. So we are starting a little late because it's Thursday. So yeah. But looks like everything's set up, which is good. And I don't think David's around to do time codes because it's Thursday, so I'm going to try to do my best as well. I do have my timestamp thing going. All right. Hello, everybody. Thank you for hanging with me. I just wanted to introduce today, do some housekeeping. My name is Scott. I go by Tannewt online, and I'm paid for Adafruit pays me to work on CircuitPython. In fact, they hired me to create it based on MicroPython in the first place. If you want to support me, you can support me through Adafruit by going to adafruit.com and purchasing hardware that runs all the open source software. It's open hardware that runs open source software that a number of us work on. Today, Jeff is in the background here as well. We'll introduce Jeff in just a bit, but Jeff is also paid by Adafruit, so please support them. If you want to chat with Jeff and I and a lot of other cool people, you can go to the Adafruit Discord server by going to the URL adafru.it/discord. Join us there. This is a deep dive where we tend to do questions for about the first hour. We'll talk with Jeff this first hour and let him go by 3 o'clock my time. It normally happens on Fridays at 2 p.m. Pacific, but I'm going skiing tomorrow morning and didn't want to have to worry about getting back for it, so I bumped it to Thursday here. So no stream tomorrow. Next week should be on Friday, but that does happen occasionally. I try to give like 22-ish hours of notice on the blog, so if you're ever wondering about that as well, keep a lookout for that. You can ping me on Discord as well if you have questions. Questions are welcome. We have 2 of us here to answer them. Otherwise, I will try to answer them as well. And I think that's it for the deep dive. The last thing is that the cat here you can see is Spook, and he is epileptic, so he does have seizures from time to time. So if I'm not communicating with the stream, it's because I'm watching him, but he's been doing really good, so I don't expect that to happen. And let me just try. Oh, look at that. I can pull Jeff up in the cat cam spot too. Okay, so let's introduce Jeff before we'll do questions, of course, but Jeff is 2 hours ahead, so we don't want to take all of his time. So Jeff, welcome.
Thank you. So as many of you probably know, I've been working on CircuitPython as my main gig for about 1.5 years now. And it's a lot of fun working with Scott, working with some of the other people. And it's a huge change from what my previous industry, where we weren't particularly friendly as developers to our customers. And it's just a lot of fun to be a lot closer to what I'm doing. And I think I'm not focused here. So just give me a second. I'm going to play with my webcam settings.
Sure.
So talk.
Yeah, so there was something I was going to say and I forgot. Jeff's been doing lots of good work. Jeff and I, it's interesting. I think Jeff did like 1 PR or maybe 2 for CircuitPython before you were actually in Seattle visiting. So you and I actually got coffee pretty early on and talked about the like, can you start working with us and how awesome would that be? So that was really cool. Back in the time where I could actually like get coffee with people.
Oh yeah.
Outside of my household, and that time will come again.
Yeah.
There was already one important question in the Discord chat, and it's do you have a cat?
No, we don't have any cats. We had cats who lived with us until the ripe old age of 16 and 17.
Ooh, that's a good cat
They
age.
went on to a different place, so
Right.
now we're without cats. Yeah.
You're without cats. And I don't want to give too much away about where you live, but it's been really cold there, hasn't it?
How's that going? I don't mind saying I live in Lincoln, Nebraska, and we've had, like temperatures, record-setting low temperatures of -30s lately here. Not as bad really as what they're going through in Texas in terms of the impact on the infrastructure. We're a little more ready for it, but it's definitely been real weather here.
Yeah, so how are you holding up? Is it all par for the course?
It's fine. Already not going out much, but I miss being able to take a walk of any length. Yeah, but we'll get up to freezing on Saturday, and then we'll get up to 41 Fahrenheit on Monday. So really getting back to those warm temperatures.
Nice. Yeah, I think we just broke 50.
Yeah.
At least for a little while. It's raining here today, but I'm planning on going for a walk after the stream as well.
Yeah.
So how would you? So you've been working with us technically part-time, technically half-time for like 1.5 years. How would you characterize the kind of like the big things that you've done for CircuitPython? What are the things that people should ask you about?
Well, the first paid project you offered me was audio, and I'm not a person with a big audio background, but I muddled through and So now often the audio projects come to me. And so I owe a big thank you to you for doing these 2 audio projects on the Pico, because I don't mind the break from it.
I'm already there with these ones. Like, I'm very excited to like get finally past him.
Yeah. Yeah. So I like dabbling in everything, and I primarily work on the core. So that means writing the C code, and I don't do as much work in the libraries. Although what we're going to talk about today has a part that's in the core as well as a part that will be in a library. At least that's how I see it playing out.
Yeah.
So, I like to be able to work everywhere within a piece of software, not concentrate necessarily in just one area.
Right, and you've been doing some guides as well, right?
Yeah, doing some guides, doing some projects. I want to get more into doing like maybe some videos, but we'll see about that. Limor's been giving me some support for the idea of doing some short videos about my own projects, so that'll be fun.
What are those projects?
Well,
for
instance,
our audience here.
Yeah, so I can't see how well I'm holding things up to the camera here. How do I get back? This is weird. Anyway, this is a circuit sculpture that I made and showed a few weeks ago on Show and Tell. And so I'm going to do a short Twitch style video just saying, here's what it is. So you take brass rods and you shape them and solder them. And, I've got a feather and a bunch of neopixels. And if the battery weren't run down, it would be twinkling away, because we need more rainbows in the world.
Mr. certainly calls it a mini Stargate.
Yeah, a lot of people have thought it looked like a Stargate. So you are definitely, here we go, we'll plug it in good company. Of course, the LEDs always have trouble coming up on the camera.
Right.
Yeah, you may get the idea.
Yeah,
definitely need the Stargate sound to go with it. So back to the audio. Right?
Yeah. And you did MP3 in particular, and like I tried to turn it on the Pico, and then it was like, you don't have these instructions, because like it does some of the like basic SIMD stuff that the Cortex M0 doesn't have.
Yeah, that, and I think maybe Audio Mixer will need some rework, because we've got the CPU power on the Pico to do these things. But yeah, some of the code just says, no, I'm not an M4, not going to do it.
Right.
So not necessarily the best distinction, but it's kind of the one that we used. Or
yeah.
In the case of MP3, the distinction that somebody else used, because MP3 and like RGB matrix is another contribution of mine. Somebody else did the real work of those, and what I did was kind of wire them together,
right.
Which is a perfectly valid kind of programming, but a different thing than being able to understand how to drive or how to decode an MP3, or how to drive a complicated matrix display.
Right. Yeah. I think MP3 is something we'll get to, but like I'm sure you've seen these too. Like, people just need UART, and I'm like kicking myself that I did the audio stuff before UART. I know Microdev's working on it as well, but it's just one of those things of like, you don't really know. Like, I started audio like 3 weeks ago or something, and it's gone longer than I expected. But then again, like, everything does, especially when it's audio. And so like, audio is going to be very cool. I think people are going to be excited about it. A lot of what I have coming in this next PR is also like PIO improvements, which were also something that I knew we would need to do.
Right.
So it's really good to knock those out. Like, yesterday we talked about this a little bit, but like, when you first started with PIO, you struggled getting the pin directions right. And so that's something I just went yesterday. I was pretty productive. Today, not so much, but I went heads down, and like, I added like for out set and side set, like just initial value, initial direction for each of those, and it's
going to make a huge difference to usability. So kudos.
Yeah. The idea that you really need a default that makes sense, whereas like the default previously was that we wouldn't touch it at all because we didn't know the state that you wanted it in. And I actually did. I know we should talk about your project, but I was talking with Luke. So Luke Wren, who works for Raspberry Pi and is like, I think, one of the core folks on PIO. I was asking some questions in the Discord for it, and my mental model of it had been like, if you enable it, like then it runs, right? The PIO state machine runs.
Okay.
But it turns out that like most of the state machine is always running, even when
Hmm.
the enabled flag is off.
So
Um,
does enable just stop the outputs from going out, or
no, what it does
what
is
stops?
it stops from it like moving on to the next instruction. So
Hmm.
the PIO has this like register that's like, here's the instruction I'm running, and if you write to it, it just it executes that instruction.
In lieu of whatever else it would have
Right,
executed.
right, and that's true even when enable is off.
Hmm. So, like, what if it's sitting at a pull instruction and there's nothing in the queue? Do you know if the instruction that you put in takes precedent,
If
or
I think if you write to the instruction register, it overwrites it immediately. But if that instruction is a pull itself, like it
Mhm.
will, there's a way to detect that it's stalled. So you would know that it didn't happen. But even when
Yeah,
enabled
that's
is
like a
on,
weird corner case. So,
yeah. The one caveat with that is that it doesn't do delays.
hmm.
So if you're doing that, like I was like, oh, could we do like single stepping? You could mimic single stepping by just having enabled off all the time, but it wouldn't do delays for you. So that's
Yeah, I
why,
was also thinking that like a PIO emulator that you could run on a desktop computer would be interesting.
right,
And
right,
I don't know if anybody's done that yet. And then David Glaude mentioned that there's a disassembler for PIO programs. So
right.
all of that is, yeah, kind of offers up different ways to approach problems in your program. But if the problem is that your outputs aren't enabled, which was my problem for like 4 days,
Right.
then that's just going to be solved by this code you're working on. And another
Yeah.
thing, you said UART, and I know it's not the UART thing that you were talking about, but this one that Dan is working on
Oh
with
yeah.
the CDC UART is also going to be amazing. And just
Right.
coincidentally, I needed it yesterday, but there you go.
Yeah. I that's one of the reasons I haven't written any code today is because like both you and Dan have really good PRs out to review. Along with
Yeah, his is a lot more
everything I do.
substantial than this one of mine, but
Yeah, a lot of it's methodical though. So David G says, so we can send one instruction at a time to the PIO. That is correct. You can just write, and in fact, in this PR that I'm working on, I have a run function that you can call and just give it instructions, and it will just run them serially. Um,
and it turns out that's really useful for this setup process that you were talking about.
right, right, right. Although you won't have to use it as much as you did before, because we'll do all the pin direction stuff for you.
Yeah, but that's what it's doing under the hood, as I understanding, is
Yeah,
issuing these instructions, but also other changes to the PIO peripheral that might be needed.
right. So I was looking at it actually, and it uses set, like it uses set instructions for all the pin stuff. Um, Mark asks, any thoughts on about Opus in CircuitPython? It's much more awesome than MP3.
I mean, there are a number of codecs that are more interesting kind of at a technical level.
Right.
I think Opus is a voice codec, so you get things like low latency and really low bit rates. And there's OGG, which, was the patent-free alternative to MP3.
Mm-hmm.
But, we picked MP3 because when people talk about, I want to play music, they think of MP3s first, so it's kind of a brandy thing, as much or
Right.
more than a technical decision to choose MP3 over OGG. And yeah, like low latency thing could be super interesting. And someday we're going to have audio, going over the USB.
Mm-hmm.
Would have a lot of possibilities, but it's a lot of someday stuff.
Yeah. Yeah. I
Not
mean,
today.
yeah. It's nothing that I feel like we don't have an open issue where somebody's pinging it once a day, like like UART is at this point.
Yeah.
And so I like if somebody wanted to provide it and merge it, like we have like the audio stuff is structured well enough that we can add things like that in. Um, but I think
Yeah.
for like Adafruit,
Although to a certain degree, it's fair to ask, MP3 is not patented format anymore. It's expired, so everyone can use it freely. So specifically with OGG, what is the use case that having both formats enables?
Right.
Why not just use an open source, no cost converter to convert it into MP3?
Right.
Because flash space is going to forever be at a premium, even if we sometimes feel like it's not right when we get a new chip.
Yeah. Well, it was funny right before the RP2040 was released, because as you know, I had access like a month early or so. Like we actually changed how much room we were allocating in the external flash for CircuitPython, and like the day before or something, like I was like, let's just make it a megabyte. Like it was, I think it was like 512K, and then it was like 684, which what MicroPython was doing. And like at some point we were like, okay, let's just make it a megabyte, and that will leave us lots of room to grow into.
Yeah. I mean, if you look at
RP2040.
what is the size of ESP32, it's a lot bigger when you bring in all of the Wi-Fi and SSL.
Oh, yeah.
But I mean,
shocked.
everything that we want to add, it takes up code, and unless we have a dynamic loading method, which is one of those other, we would love to have this, but it's not a top priority. Everything comes out of one fixed budget instead of coming out of a flexible budget.
Right.
And yeah, I agree with Object. OGG has, by virtue of being newer, OGG has been able to make different trade-offs, and I think at a given bit rate, it has better audio quality. I don't have much of an argument with that statement.
Yeah, but I think in terms of work priority for us, like, and I'm trying to be clearer and clearer with people about this when we talk about what CircuitPython will have, is like, there's a difference between what CircuitPython will have and what folks paid by Adafruit are going to work on adding, right? And I'm lucky enough that I feel like I have influence over what that is too. But if I had to pick what audio work we do next, I would pick getting MP3 running on the Pico, like on the RP2040.
Yeah. Other fun MP3 stuff that I think it enables new use cases is, we've talked a number of times about streaming them from, say, Wi-Fi.
Right.
And that would be fun. You'd have your podcast player, CircuitPython, but the Wi-Fi coprocessors aren't quite fast enough, and the audio support on the ESP32S2, we just haven't got solid enough yet to make that a priority. But that's another fun audio item we might do someday.
Right. Yeah, and Neradoc points out, like, where would you store that? Like, you'd have to, like, the board's flash is not usually big enough, so at some point you need SD, and then the SD has to be fast enough to read as well.
Yeah, SD is really fast enough now in CircuitPython. That's another thing where I did some refinements. We moved an implementation of SD into the core, and that gave us a good speed up. And then some microcontrollers support SDIO, which is a 4-bit at a time protocol for SD. So yeah, the SD cards are way fast enough to play MP3s. In fact, you can sometimes play multiple streams back with Audio Mixer. I did a demo of that. I also did a Trellis version of it where it was just some tiny little samples as a soundboard. That was fun. But were we going to talk about audio all day today, Scott?
We can talk about whatever you want to talk about. I mean, like, Limor started coming on this because she watched the stream and was like, wow, it's really casual. And I was like, yep, just ping me and you're happy to do that. David G did ask, like, would MP3 decoding run on the other core? And I don't think, I really am tempted with the Pico, with the RP2040, to really leave the second core alone as much as possible, because I do want to make it available for user code at some point. So I don't want to just use it internally necessarily. I kind of like the idea that we kind of have going with CircuitPython already, is like we run on one core. When we have stuff we need to do, we'll do it. We'll deprioritize the Python code. And I'm okay with that. I think it would be cool to use the second core for something else.
Yeah, I don't know what multiple core, multiple thread is not my rodeo.
Yeah, it's not mine either. So, which is part of the reason that like, it's frustrating for me when I see comparisons with, like, MicroPython to CircuitPython, and it's like, oh, like, CircuitPython doesn't have threading, and that's why you shouldn't use it. And it's like you were getting to before, like we really try to focus on the like what is the thing you cannot do, and that's not like threading. It's just like I need to do these actions all at the same time. Like that's what we want to hear. We want to hear about the project you're making, not the feature that you're missing.
Yeah, that's a really good way to put it.
And it's really hard, right? Like it's really hard to not get into a features for features sake sort of mentality. And I think Adafruit's guides are a great forcing function for making sure that you don't, which I think is why Limor is totally happy to have you do guides, is that like it ensures that you're still it ensures that you're operating at the right level.
Yeah, it helps you stay grounded. I mean, another thing in contrast to my other job is, I love the software and I use the software, and in a lot of people, they write software that they don't use or don't enjoy using. So yeah, that's a huge perk. But let's talk about LEDs. I want to show you this project,
right,
which if you were on Show and Tell yesterday, you would have seen it.
Right.
But oh, I've got a cabling problem here. Hold on.
Always. I always have cabling problems.
Let's see. There we
while
go.
you're that, let me just answer. There's a question about not that secondary CDC on the M0, but also the ESP32S2 don't have enough USB endpoints. That is correct. That's my understanding based on Dan's PR. So you'll have to use something else, or modify the build to turn it off to make room.
That's which microcontroller?
The S2 and the SAMD21.
Yeah.
But he found enough space to actually fit in the other stuff. So like the SAMD51 will have secondary CDC by default, along with pico and NRF. I think will all have that extra one. All right.
So this is in some ways a because you can project, but we've got the pico and what's called a shift register here on the breadboard. And so the pico sends out at a very high rate, like 12 megabits per second, a bunch of data to the shift register. And then the shift register sends it out to these 8 individual neopixel strips using the PIO peripheral.
Right.
And the main advantage of this is, well, first of all, it gives you more freedom for wiring up your strips, because you could kind of radiate out from a central point instead of doing this zigzag thing you have to do.
Right.
But the other is it's actually nearly 8 times faster. The process of actually sending the data to the pixels is 8 times faster because it's happening for all 8 simultaneously.
Right.
Whereas if I took these strips and laid them end to end, now it takes longer. And ideally, the best possible speed up is 8, and we measure 7.4, so that's great. There are 2 parts to doing this, and one is the program that runs on PIO to create the waveform that neopixels need. And then the other is to take the original data as PixelBuff describes it and get it into the form that the PIO program needs, because it needs to take, say, the first green bit of the first and 30th and the 60th pixels and send that out together. Then the second bit of all those bytes, and then eventually goes to pixel 1, pixel 31, pixel 61, pixel 91, and so on. And it's just a big mess of moving bits around. And so this pull request that Scott mentioned reviewing and talking about is the one for doing the bit manipulation part of this whole equation.
Right. So I don't think people fully understand how cool this is.
Well, in some ways, this is, what did it enable is a hard question to answer. There's the increased speed, and there's the freedom to lay it out differently. So like for example, well, I won't be able to necessarily find the numbers again, but say you had 25,600 pixels. With the NeoPixel show, you can only get 1.3 frames per second, but with this, you can get nearly 10. If you have a more reasonable number of pixels, like say just 2,500, then that's going at 100 frames per second instead of 13.
Right.
So I think the speed is going to be the biggest. As you get a big number of pixels is going to be the biggest thing.
Mm-hmm.
Um, but also part of this is just proving the concept of what are useful things PIO does,
Right.
and as my learning exercise.
Right.
And this is a concept that Limor had and tried to implement on some other microcontrollers and couldn't. So we proved we could do it. But so I'd be interested to hear what you think the kind of the use case. What project does it enable? If you have an idea about that.
No, I think you're right on the money. I think in particular it's speed. Um, like people don't realize when they're doing animations on neopixel strips, like how the amount of time it takes to transmit the data is directly proportional to the longest string, right? Like the number of pixels in the string.
Right.
There are some problems with like how do you compute all the colors, especially if you're doing all that math in Python. But generally, like that's a big bottleneck is just transmitting the data because it's an 800 kilohertz protocol, and that's per
And each
bit, right?
pixel takes 24
Right.
bits.
Um, so Alvaro says, what shift registers are you using? Breadboard, stemma. How fast can it go, and how many strips would work?
So
As many PIO pins are available.
so this is using a 74HC595 shift register, and I think it is clocking it at something like 19 megahertz to do a strip of 8. I kind of did the math, and I think, or not, to do 8 parallel strips. I did the math, and I think it might be possible to get up to 16 parallel strips by using 2 of the shift registers, but I don't know, and it needs more core code because the core code is very optimized for the particular reorganization that it needs to do.
Right.
And to do more than 8 bits would take another piece of optimized code, and we're just not going to do that right now at any rate.
Yeah.
And yeah, there's another way of doing this, so this uses just 3 pins on the microcontroller, which go to the shift register.
Right.
And then the shift register has an output for each strip.
And a
There's another thing that
single state machine, right?
Yeah, and one state machine. There's another thing we could do I think, how many different pins can you drive by? I have to use both set and out. So how many pins can we drive at once?
So are you using delay? Well, set can do 5.
No, I don't do a delay.
Set can do 5 pins, and out can do up to 32.
Okay. The way it's set up, I use both set and out. I think I can get around this. I think I can change it so it uses out. I'm not sure. But for now, I think we might be limited to doing 5 strips without the shift register just by doing them direct from the CPU. But that's not what we've investigated yet. And there might be a way to do more.
Right.
I don't know.
Right.
And yes, you should always order more NeoPixel strips because you should be constantly giving them away to your friends and making them hang a sculpture on the wall.
You can also cut them apart.
Mm-hmm.
If you do have one big long strip, but you like the idea of speeding it up, you can cut, and then you will have to solder to them, but you can cut and solder them together to make it happen.
Yeah, I am not the best when working with wires, so I deliberately chose some strips of modest length that I could reasonably just pick up 8 of them.
I mean, that's totally fine. Like
yeah,
that's a good option. Like I have NeoPixel strips around the front windows of our house, and like
yeah, you showed those at Christmas time. Those were cool.
Yeah, they live there all year. But I like every year I have to like go in and like fix the wire joints in the corners, because I have like it soldered down. It's a pain. So yeah. If you can just afford to buy it, then that's the easiest option for sure. Let's see. There was one other question, and let me snag the time first. This is probably not cost effective, but could you replace the shift register with a machXO tiny FPGA, and instead of optimizing the code on the side of CircuitPython, just do it on the FPGA?
Yeah, I think that would be great for somebody who understood FPGAs better than me.
Exactly. And Emmett is asking, what is the RP2040? The RP2040 is it's the name of the chip on the Raspberry Pi Pico. It's a new microcontroller chip by the Raspberry Pi Foundation or Raspberry Pi Trading. That is the latest hotness and has lots of RAM and 2 cores and PIO in particular, which is really interesting. I feel like you said you turned the corner for PIO. So I imagine there's a lot of folks that are watching or will watch that haven't jumped into PIO land yet. How would you recommend that happening? Like, what tips or tricks would you give folks?
So if you get the RP2040 data sheet, there are some examples in there. And the example I recommend starting with, let me back up and say, this assumes you understand what SPI or SPI is.
Mm-hmm.
Start with the example for SPI because it's pretty small and it lets you learn a good number of the concepts. I think you learn about side set and you learn about pulling and pushing and these other things that you need to do for a basic program in PIO. And the other thing is wait for this pull request of Scott's so that it will automatically set up your pins, which need to be outputs for you.
Right.
And that will bypass the thing that left me stuck.
Mm-hmm.
And I think, it helps that I have some familiarity with assembly language.
Right.
But it's just a list of instructions. If you don't get into branches, it just starts with the first one and does the first one and the second one and the third one and goes back to the top. Right. So it's like a program where you don't have a for loop or an if statement, just at a very basic level. It's just a forever loop, which a lot of us are familiar with from other programming environments.
Right. And
just dive in, give it a try. I used a Salier logic analyzer to kind of see what was going in and going back out. So that's like a really nice tool for understanding what's going on, but you can also run them really slow and have it show on an LED. So I forget who was discussing this on an issue, but there is an example of just creating a square wave. Right. And you can run it slow enough that you can see it on an LED turning on and off. And so directly visualize what your program is going to do. Mm-hmm. And so, yeah, all the things, but just it's a new learning experience in a new language.
Right. David asked, so is Limor going to do a board with that shift register and 8 connectors for NeoPixel strips?
I don't know. I'm thinking of doing an OSPark board because one of my 2021 ways that I would like to grow is to do more circuit boards. And if I do that, I will mention it on the Discord because, yeah, the breadboard got a little out of hand, but if it had had those 3-pin connectors for the strips, it would have gone together so fast.
Right.
And yeah, been much prettier.
Yeah, I think if I had to guess, I would probably say no. Like we already have the NeoPixel 8, right?
Which this won't work with because it is using the shift register and NeoPixel 8 does not. And that would be one interesting reason to look into the version that can do them independently without the shift register, but by using up more IO pins.
Right. And that's what I'm thinking. Like, I think like the transpose thing that you're adding is really convenient because that's what you would need for that case as well. And then we'd be able to use NeoPixel 8. That does assume that like the pins that that NeoPixel 8 uses are consecutive in the
from the point of view of the RP2040. Yeah, and I haven't looked into that.
I don't know if I think Limor already has the PCBs, but if not, we should make sure she doesn't.
Had a Rev A kind of PCB that she's shown on some videos.
Right. I mean, I've got one, right? But
you've got one, yeah.
Like when we were talking about what the pinout would be, I don't think we
are the panels on the
yeah
being
exactly
fabricated or not. I don't know.
Right.
There is some flexibility on that board with solder jumpers to change.
So that might be do it.
Although I think for a couple of pins, there are two choices. So it may not be enough choices
May
for
not be
us.
perfect.
And I'm not gonna get into looking that up right now.
Yeah. Well,
And I don't know,
we could take a look. We'll make sure.
is the schematic of the RP2040 Feather, I assume that's something that is not released yet, since it's still not a released product, right?
Right. I don't think it's public.
Yeah.
No, but
Yeah. So otherwise, I'd assign
I
it
have
homework.
access to it if we want to check it. We should check with Limor if nothing else.
Yeah, it would be fun if that worked. And yeah, that is going to build on this same bit manipulation routine,
Right.
but it wouldn't require the shift register, but it would require 8 I/O pins or 5 or 3 or however many you wanted of independent strips.
Right. So, Slinky, I see your question, but there's two folks that had this. Oh, let me take a time. David G said, need an RP2040 signal analyzer to work on PIO and see what I'm doing. And Deshipu also said, it would be interesting to do a signal analyzer with PIO.
Didn't someone work on that?
Yeah,
I swear I saw it on Twitter or something.
No, Mark Gambler, who goes by Gambler, that's not his last name. He did a show and tell, I think, of it. Basically, like the PIO is really good at just sampling data, and so he just ingested it and then like saved it to his computer, transformed it into a thing that like Pulse View could do. Like this is something I started and I really want to do. Yeah, Mark says I did that. I really want, like, I had this project called Tiny Logic Friend, which was my, like, I would like to have a standard protocol for logic analyzers over USB. That I haven't been able to find one. And one of the constraints that means that the existing protocols don't do is I want to be able to send pin names back to the software. So that like you just take a board, you plug it in, it reads the pin names off, and then shows you the pin names in the capture software. And I don't know of anything that could do that. So that was kind of the crux of what I was doing. So, yeah, it's something I'd love to do and like connect it end to end, so it's really easy to use. There are examples using the Pico SDK to do capture, but yeah, there's just so many things I want to do. And I've got to remember the things that are most important. Slinky Tangle asked, can you talk a bit about implementing a high-speed counter running in the PIO? So I'm not sure what you're counting. If you're counting edges, you can't increment, but you can decrement.
Which just means you have to think of the numbers as being negative numbers.
Right. So yeah, you have the ability to wait for an edge or wait on a pin, so you could just wait until the pin is low and then loop around and then wait until it's high again and loop again.
Yeah, I have a feeling that what you're going to want to do, if this is like for frequency counting, which is an interest of mine because it's adjacent to timekeeping, I think you're going to wait for the value to be low, say, and then once it goes low, you'll loop incrementing or decrementing X until it goes high and goes low again. Mm-hmm. And then you'll send as a return to the Python program what the value of that X register was after it saw whichever edge you were waiting for.
Right.
And there will be some details around it, but because I think you'll have an instruction to decrement X, mm-hmm. and then you'll have a branch instruction conditional on the pin that you're checking. So that's 2 instructions. So you should be able to get up to 125 megahertz over 2 of like fidelity of your counting. So your counts will be at, what is that, 62.5 megahertz, which is really pretty good.
Yeah, and I think the PIO gets all the love, but there is like the PWM peripheral can do capture stuff as well. So if you want to like wait for an edge or count when something is high. Like you don't have to use PIO. And I think like people are like, oh, we're just going to use PIO for everything. And it's like, well, you don't need to. You can,
Well,
but you don't need
the
to.
neat thing about PIO in CircuitPython is it is a lot more low-level, fast programmable
Right.
than Python code is. And so if you don't want to go changing the core, but you do want to be working in CircuitPython, because like making the rest of a frequency counter kind of appliance in
Hmm.
CircuitPython would be way better than doing it under another environment. But
Right.
you need that core part
Right.
of
Right.
of counting your pulses. So
Right. And Slinky says, I'm reading a 2 megahertz pulse from a Zeeman interferometer. I don't know.
I think that would be well within the bounds of PIO to
Right.
do a 2 megahertz.
I don't know what a Zeeman interferometer is, but I'd love to know. But yeah, it sounds like you want like, I assume you're wanting like density, so like how many counts over a period of time um, you want from an instrument that does a 2 megahertz pulse. Um, I'm guessing. Emmett says only 2 spy buses. That's a pity. Yes, that's true, but in practice, I haven't seen people use more than 2. And if you really need more than 2, you can do PIO and do more than 2.
Yeah, with PIO you can do some more for sure.
Right.
There are so few kind of sensors on SPY. Well, from Adafruit anyway. Adafruit is all in on I2C.
Right.
But you've got one for your display bus and one for your SD card bus if you need it. And I don't know what else you would really need to do with SPY. But if you have a SPY
Right.
peripheral, that sure is a valid
You could also share
option.
spy buses just by having separate chip select lines as well. It's just really bandwidth that you don't have.
Mm-hmm.
I want to say hi to Summersoft, who dropped in the live broadcast chat.
Oh, I didn't see that. Hi,
Yeah,
Summersoft.
and says RP2040 PIO kind of reminds me of the IO on the parallax propeller.
A chip I never learned.
I've not learned it either. I checked the new products at DigiKey under the like MCU evaluation board category.
Yeah.
I've seen the Prop 2 board is now available on there. So if folks are propeller folks, check that out. I think the critique that I've heard from Limor about it is that it's just like really power hungry. Um, so that's one of the reasons that we haven't taken a look. It's also like completely different.
Yeah, it's a very different system.
Yeah.
I've tried to just at a casual level read some of the video generators, for instance, and whew, there's
Right.
a lot to pick up there before you can really use that thing well.
Right. Right. Yeah, I think the PI is really neat. Yeah, I think we're just going to see. Slinky Tangle says, yes, if I could read it at PIO speed, I could replace an FPGA currently in my design. The Zeeman can measure distances to sub-micron accuracy. Yeah, that seems
This
doable.
is like time of flight kind of thing, I bet.
I don't know. Emmett Ray says, I Googled Zeeman interferometer, but I'm too stupid to understand what it is. I'm sure I'm with you.
No.
You just
Stupid
don't
is
have the
a harsh
background.
term, but there are so
True.
many things where you need more background to really get into it, that's for sure. But
Right.
it's not stupid.
No, not stupid. We're all stupid in some areas if that's your bar. There's lots of things I don't know about. Um, so I don't want to keep you super long, Jeff.
Well, did you
Because
want to actually get into any of this code, or
well, there David says so. No talk about clock and time. I did just so another thing that you did is I reviewed and merged your URandom
oh yeah, that
fix
was
for the
a fun little
pico.
diversion.
Um, do you have any time thoughts as we run out of time?
Well, I did notice some weird results out of time.time on the RP2 today, but I didn't figure them out yet.
Right.
So yeah, I don't know.
That does That does bring me to what the way that I was hoping to close talking with you is like what are the things that are upcoming for you? What's on your radar? What are you excited to work on? If you want to do more PIO, what do you want to do with PIO?
Well, kind of the other main idea I had for PIO, I've come to understand is a little bit of a silly waste of time. Just as a proof of concept, I'd wanted to run some like RGB, or not RGB, some of those 7-segment LED matrices direct from the IO, from the PIO. But there are I2C devices that do that, and they do it a lot better. So
Mm.
we're probably going to leave that aside. Um,
That does get, I think, to some use of PIO that I think we're going to want an API for at some point, though, of like, I want to share a memory buffer with it, right? Like, I want a
uh-huh.
memory buffer and I just want it to loop over it, right?
Yeah, that's the kind of the core functionality that requires.
Right.
And like, say, you must have kind of done this with the I2S, where you're continuously giving it more data, but we can't do that from Python land
So,
yet.
no, I don't actually
No?
do that. What I do is my I2S PIO code will save the previous value. And then if there's no value in the FIFO, it will just produce it again.
Well, I mean, in the general case of
Oh,
while
for
you're playing an audio sample, it's continuously looping, but that whole audio sample isn't there at once because it could be an arbitrary
right, right.
wave file. So it's looping over one or two DMA buffers. I'm guessing based on how other stuff works. And while the one buffer is being used to produce the audio, the other buffer is waiting to be filled by
Yep,
the background code.
right.
And so that it's that thing of continuously reusing one or two memory areas
Yep, yep,
that is similar to what we're talking about, but
right.
not exactly the same.
Yeah, and there is this special case as well as if the sample you're playing is a single buffer. Like if all you,
Mm,
it's kind of like what wavetable is the right term, right? Where you just have like one sample you're gonna loop.
right.
There is a special case for that, and it's interesting the way that it works on the RP 2040 because the registers that you write for a DMA channel are live registers, which means that like as you increment, your read address moves. Um, and
That would seem to provide some challenges in getting the code right.
yes, but it's also very convenient if you want to know where it's at.
True.
But the challenge is that if you have like, I want to loop over this same buffer the whole time, like if you want to run that same DMA thing again, you actually have to like copy the original value back. And the way that you do that is you have a second DMA buffer or second DMA channel that's triggered by the first that copies the configuration back into the same registers.
Oh, I said but it turns out I didn't know at all what you were just about to say.
Yeah, the DMA is kind of like weird in that it like self-references and like you can self-modify with DMA. Like theoretically, you could have like a sequence, like you could be DMAing a sequence of DMA setup code. And they actually have like aliases for the DMA registers because you can you can trigger DMA based on like a particular register write. And then there's like 4 aliases so that the last register that you write is like there's 4 configuration registers and there's permutations of the ordering so that the last register you write is the one that you trigger. And you have options as to what that register actually is.
I think I almost understood what you said.
Yeah, it's weird. It's just like if you're writing a DMA register, you have to be aware of whether it's a trigger one or not.
Hmm.
And you'll see that in the like Pico SDK API, there's like this trigger Boolean flag on all of them. And if you look at the code, it says if trigger, use write to this address. If not, write to this other address. That's not the trigger, which is pretty weird. Slinky said the Zeman is a stabilized laser for optical measurements, which is pretty wild. But yeah, I think yeah, the PIO is just going to get it's going to be more and more interesting what people could do with it. Just as like Jeff and I are pretty smart, and we're like just starting to understand like the basics, the basics of it. So that's true for a lot of folks that are just seeing it. So it's gonna be neat. It's gonna be super neat.
Well, it seems like I'd better plan to come back another time and talk about time because there's at least one person who's interested in that.
Yeah, I mean, I don't know a lot about it myself, so you know, and I think you and I were talking a little bit earlier today about how like, oh no, I haven't really looked into it. I haven't really made sure that it actually works, and that's kind of one of the things that we want to do later. Let's see. We got an unrelated question about extracting ID3 data from an MP3 file. I don't know something off the top of my head, but I'm assuming that we could do something, or there's like a program that will do it for you.
So I would look into whether there was a regular Python library for doing this because, you can just open the MP3 file as a file and then run Python programs on the content. So there's bound to be an ID3 tag reader that's just coded in Python. So bring it over to CircuitPython, fix whatever's broken, and then you can read the data. I did not do that in my MP3 player project, but that was kind of running out of time to get the project done rather than it being an impossibility.
Ooh, look at that. I thought we would do. I know you didn't want to be here more than an hour.
No, that's fine.
But
oh, now there are two of me.
Now I had to cover you. I thought we'd do the pull request, although we did get another question. MD Roberts 1243 says, "What's the best resource currently to understand PIO?" I think it's a mix of read the datasheet and then try to apply it. And I think the way that I would recommend people like applying it is actually, we have the PIO ASM library, and I'm putting all of the examples in there. So when I implement something like neopixel with it, I put the examples in here. And I'll do that. I have I2S and PDM as well. So this is actually like, read the datasheet. The Raspberry Pi docs are really good. And then take a look at these examples for CircuitPython. All right. So, and Johnny says, ID3, EYED3 is a Python tool for working with audio files, specifically MP3s. Let me move you off screen. Oh no. I can't move you off screen. Yeah, Mark says the datasheet has great examples as Pico examples and just playing with it.
Oh yeah, don't forget Pico examples.
There's Pico examples. There's also Pico extras, which is the examples that they don't really want to document. They don't want to have really good documentation for. But,
it is challenging to really document things. That's something I'm understanding more and more as I work in the Learn system in particular.
Right.
To write something that is going to be useful for people at all levels, or even just, one or two levels that you think you're targeting. And so I'm so happy to have people helping like Anne with, getting those guides good and hopefully growing a little bit as an author as I do it.
Right. Yeah, and Katney's really good at that too. Okay, let's do your review so that you can get out of here. So I think I've showed myself a review on the stream before, but folks may be new. So what this is the dark version of GitHub. We have two videos, and so it's kind of hard to manage being able to see both Jeff and I. But so this is a pull request that Jeff did. It's 4219 if you want to follow along. A pull request is someone is proposing changes to your version of the code. So in this case, our version is like the shared version of CircuitPython, which is the github.com/Adafruit/CircuitPython. And then this is a particular proposal that Jeff has made from the jepler bit transpose is the branch name. So he's made some changes. He's proposed moving those changes into Adafruit CircuitPython, and that's what a pull request is that you are requesting somebody pull your changes into their version. And so the way that we have it set up in CircuitPython is that Jeff, even though Jeff has access, he cannot do it directly. He has to have somebody else take a look at it and review it and make sure it's reasonable before we merge it in. So I did an initial review earlier today, and I made these comments. I said, like, hey, please. So maybe I should pull up the full thing. So what this is we were talking about the cool, like, 8 strips at a time thing that Jeff did, and he needed some code to be able to move the bits around really quickly. And the nice thing about CircuitPython and MicroPython as well is that you can use C code to do things that you need to do faster than you can do in Python. So what we're looking through here is what Jeff is doing is he's added a new native module to CircuitPython now called bitops. It was not originally called bitops, so you might see that there's a comment from me that says, hey, can you change this? And I'll mark it as resolved, although Jeff could have marked it resolved as well. So this is a perfect...
It's better because it makes it disappear and then you don't remember it and maybe you don't know it was resolved.
Yeah.
So I can do it either way, but that's why I left it.
Yeah, and that's fine. I also try to, like, I don't necessarily do that because I do a lot of reviews. So, like, if you say it's resolved, I'm like totally okay.
Yeah, I can only get away with that a couple of times.
Let's see. Sorry, I'm trying to do time codes as well. Let me just drop one in here for PR review. Okay. This is what I get for being on Thursday. David is nice enough. DCD is nice enough to do time codes for me, usually on Fridays. Okay, so we're going to go through here. So we're going to call it bitops. And so this is like this MP config port and this Pi CircuitPy stuff is all very boilerplate. So if you're ever going to make and this is a good reason for me to take a time code, right? Is that this is where we explain how to add a new module to CircuitPython.
Yeah, there are a number of things you have to do, so it's good to know them.
Yep. So CircuitPy definitions.mk is like makefile level stuff. And then this mpconfig.h is the C level stuff. So it's important to note that anything that happens in C land can't impact makefiles. That's why there's like 2 places that you have to do stuff. And it's very formulaic. If you look at this full file, you'll see that it's like a lot of just this.
Just repeated over and over.
Yeah, which has influenced what I would love to see as a build system in the long run. But, I can't do everything. So this CircuitPy mpconfig.make is just setting the default, whether it's building or not. You might be like, oh, that's kind of like a lot of work and blah, blah, blah. But at some point, it's okay to have APIs that are like a little bit tedious as long as they're regular, meaning they're consistent. It's like, yeah, it kind of sucks, but it's also like it takes you 2 minutes because it's the thing you always do. Okay, so let's see. We have 9 total files, and we've already looked at 5. Shared bindings, bitop initc. So all of it's going to be in initc because we don't actually have any objects in this case.
Right.
And for those who are new to CircuitPython, shared bindings is the place that we document what the Python API is, and we also do the conversion from Python objects to C API under the hood. Oh, you could change this copyright. I meant to mention that.
Oh, yeah, I should. Yeah, because this is all fresh code, so I should change that.
Yeah. I'm bad about it sometimes. So this is so anything with a / bar. Let me make it bigger. So anything with a / bar is going to be pulled out as Python stub documentation. So the very first triple quoted string here is the module level documentation. So this will be documentation for bitops. And it just says routines for low level manipulation of binary data.
And
Totally.
maybe we'll have others in the future. We just don't know what they are yet, so it's hard to be more specific
Yeah,
than
totally.
that. I think you were on this track that there may be some interesting things we can do for manipulating bitmap data just beyond this.
Yeah, I expect that to be the case. Background is that if you look at this PR, you'll see it was originally called like bit transpose, but Jeff has renamed it at my request. Okay, so there's one function called bit transpose. It takes an input buffer and an output buffer and a width, and also returns a writable buffer as well. So this is actually where I do most of my reviewing, and Jeff probably has realized this. But when I do most reviews, I care most about shared bindings and what the APIs are.
Yeah, well, the rest you can fix later on, but when we put something in a stable release of CircuitPython, we are stuck with it for at least a stable release version. So it's important to get that right.
Totally. Yeah, and like,
and I've noticed my inconsistency here. Just to get real specific, I have underscore typing in 2 places, and I don't have it in 1 place. Do I not need it in any of the places?
What place are you? What's the third place you think it would be?
In def bit transpose, if you scroll over to the return type, I omitted underscore typing dot. Now I'm just wondering whether that's maybe not needed at all.
I mean, the thing that would fail if you got it wrong would be the stub stuff.
The documentation, I think, would fail to build.
Yes. Yeah. So I mean, if the CI passes, it doesn't really matter.
Well, I should go back and make it consistent.
Yeah, sure. I think the writable buffer is a bit weird because it's actually like a union of a bunch of different types that we've defined. Like, it's not a Python thing. It's something that we actually have like a file that says it, just to make it easier to define like when you take readable or writable things. Assembling each output byte with bits taken from each of the width different input bytes. Yep, that makes sense. This can be useful to convert a sequence of pixel values into a single stream of bytes suitable for sending via parallel conversion method. Right. Number of bytes, multiple of width, blah, blah, blah. Stride is equal to the length of the input divided by the width.
Yeah, so this is what I was saying, where you take pixel 0 and 30 and 60 and 90. So you could have thought about it the other way, where you take, pixel 1 and then pixel 8 or pixel 1 and pixel 9 and pixel 17 would all be on the first strip, and I had to make a choice, and I decided that it would make more sense to a usual person if all of the pixels on one strip came first when you looked at your whole buffer with all of the strips in it. So,
right.
But it was a choice that I had to make as to which of those would be.
Yeah, I think it makes sense to me. And it returns the output buffer again. So this is all boilerplate stuff. This is where my eyes kind of blur. Although it is good to note that, like, one thing to check when you're checking argument validation is just like, if it's like a new port of something that exists, you might want to like make sure that the strings are the same, like the error messages that you produce are the same, because anytime you add a new string, it means it has to be translated to, I don't know what we're at now, like 12,
15 or 16 languages.
15 or 16. Yeah, and that's something we haven't talked about, but Jeff was the person who set up Weblate, which makes it much easier to translate CircuitPython. For those of you who don't know, we have versions of CircuitPython for these 15 and 16 different languages, and what changes is primarily the error messages, but also like the other messages that you see kind of regularly as well. The goal being that like having errors in your language make it easier to understand what the problem is.
So it's 17 languages, and that is excluding pirate English.
Oh, is it?
Yeah.
That's good.
Yeah, so you can't, unfortunately, translate pirate English using Weblate, although that's just kind of there, I don't know, for fun, for testing, for...
It was. It was a meant of like, oh, we'll just like have a language that you can use to understand how it works. Which I guess is kind of like that was pre-Weblate, so it reminds me that maybe we don't need it anymore. I don't know. Although I'm hoping to get Pimoroni on board, and I bet they want to use it.
That will be the killer feature, huh?
Right. Yeah, not HID or audio or MIDI or any of that stuff. It's the pirate version. Yeah, Summersoft added pirate, so kudos to them for doing that. Okay, and then here's the actual implementation. So I click through this other shared bindings that just basically has the one method that is called. And now we're in shared modules. So this is all like, it doesn't care what CPU it's on. It doesn't care what like microcontroller it's in. So it goes in shared module, not one of the common HALs. So you cite where you got this stuff, and I glanced through this. This is one of those things where it's like, it's much easier to just test, right? Like, I could try to understand how this all works, but testing will
it's fair
quickly
to say
tell you.
I don't understand how this transpose function works. If you have the Hacker's Delight book, yeah, it explains this. It shows some ASCII art diagrams, but how it actually is achieving transforming from the one way to the other, it presents. This is a great book, by the way. If you have any interest in like low level, how do I work with bits and numbers in computers, kind of beyond the basics of and or XOR and arithmetic, it is a fascinating book. I love it. But a lot of it, even once you read it, it goes over your head. But this way of doing it is twice as fast as doing it in a straightforward way with a couple of loops, because it can use these bit manipulations in a really clever way.
So Alice tries says, it's useful having a language you can use to check that you've got everything localized properly too. True. And David G says, is this somehow related to Microlab matrix manipulation?
It's not related to Microlab. I mean, if you're working with matrices of integers or of real numbers, then Microlab is going to help you out. But it didn't have this particular kind of thing because it doesn't have a lot of routines for working with individual bits. It's concentrated on 8-bit numbers, 16-bit numbers, and real floating point numbers.
Right. Which makes sense to me. Anyway, so it looks good to me. There's just like that one copyright that you probably want to update.
Yeah, I updated it to 2020 in my working file, so I'll just go fix that to 2021.
Well, this one it's not even attributed to you.
Which one wasn't attributed? There was the one that had Roy's name on it.
Yeah, that's the one.
Okay, yeah. Yeah, I changed it to 2020 and Jeff Epler for Adafruit Industries, but then I realized it was 2021.
It feels like March 2020, right? Isn't that the running joke?
Yeah.
So just to finish the process. So what I did is I said, hey, want to update this as a comment? You can see it's pending, although I'm blocking it. So there's the comment. It's pending. What I do is you go finish your review, and then
it says request changes, I think.
Yeah, let me move myself.
That third check.
Yeah, so there's a request changes thing, and I can say I would probably say like just one super minor thing. It is important to note that we do have the setting for, like, I could approve it, but in CircuitPython, if Jeff or anyone pushes to their branch, it will undo any approvals.
Yeah, so it doesn't really do you much good to say it's fine except for this. Still, he has to come back after I make that change.
Right. So what Jeff can now do is, well, actually, we can mark these resolved. So I'd require the output buffer, which you did. So we can just say resolve and document it independently in neopixels, which you did as well. So we'll resolve that. And so there's just this one thing, and it's important to note that these checks, the check and the cross, I guess, are the state of this continuous integration system, which automatically tests code. You can see here.
Before I hope that one that failed was the one that I canceled, but I see that it was the newest one, so I must have two problems.
You might.
I just added that writable buffer without the typing dot in front of it, so I bet that's what failed and that the CI caught it. So
Yep.
answered my own question.
It looks like that because so the way that we have the CI set up for CircuitPython is that we do these three builds first before we build all of the other board, because we build every artifact. So we build like 3,000 versions of CircuitPython every time we have a new change. But in order to do that,
somebody proposes a change even.
yeah, so every time we need to do that, it needs to pass at least these three things to start. So if you ever have something fail, here's how you find the problem. You hit the red X, and then you hit details, and then it will show you run failure, which is not very helpful. But if you scroll up, you'll see translations. Translations failed. So
translations failed. Well, that's another common way to fail.
it's very common. And that's part of, because it's so common, that's why we put it first, right? Like,
right.
CI,
yeah.
like
someday we'll figure out how to make it a part of pre-commit, and that will be even better.
Right.
But there are some tricky things about that.
Right. And I know you looked at that already a little bit. So the other thing that I'm not saying is that, like, yeah, we build everything, but there is a limit to how many things we can be building at once, and that's like a limit for Adafruit broadly. And so anytime we have a CircuitPython build that's building, like, it has like 60 boards at a time that it builds, if we have multiple pull requests and merges happening at once, it can actually back things up. So by having this initial check of like make translate is something that's often needs to be fixed, and doing that before we go to that like build everything just means that like we don't have extra builds that, like, we could build all of the boards here and that would be helpful potentially, but like we'd also still need to build them all again. So it's just a bit of a short circuit to make it a little bit better. Any last questions for Jeff? Or so what's left on this is that Jeff will push the new stuff, so we can see requested changes here. And if I go back,
and then I'll have my translation fix, which I already pushed fixes for most of what you asked for, but I didn't know about this translation problem because I didn't look. I should have looked.
Right. So under files change, you'll see 7 of 9 are viewed now. And so if we just look, this is the one that changed. So 2021 now, and this one as well. And I'm actually surprised that I didn't. I'm in the mode of.
If you can go up and see just from a range of commits is another useful way to visualize it. So yeah, why don't you show that?
I don't know how to do it.
File filter? Is it the no?
Oh, view changes since you last viewed. Here we go. Yeah, this is what. So if you hit changes since you last viewed, you can see the exact things that were
I swear GitHub looks a little different each time I use it.
I know, and I'm like, I have my like settings and stuff on it too. But that looks good. And the translations aren't pushed. So
right.
I won't bother. This is resolved. But I'll wait to approve.
I'll have to go back through with make translate.
So yeah, usually Jeff and I would not be talking to each other while we do this process. Usually it's something that like I regularly do all of. I showed this on a previous deep dive, but I go through all my email. I open tabs for all of the stuff so I get GitHub emails about reviews like this, and then I open tabs for everything, and then I go through all those tabs, and I do that once a day in the morning. So like my process, I did this review this morning, and unless I had like 20 minutes where I wasn't going to be able to do anything, I would probably not take a look at it until tomorrow afternoon. It would usually be morning, but
the real reason to get on deep dive with Scott, because then you can review your changes for an hour until it's acceptable.
Yeah, we can get all of the good stuff in. And now that make translate is pushed, we can do view changes again, and now I can approve it, and then
Hopefully, hopefully we'll be able to merge it in then
right.
once the
So
checkpoint comes back.
I'll approve it, and then what will happen is that in an hour or two, the CI will be finished, and because it's approved, Jeff would be able to merge it. I wouldn't have to merge it. And there is actually a setting we could turn on that allows you to auto merge once the CI is done. But
No, I don't know if we necessarily want to do that. So I'll go in and cancel the earlier workflow.
you shouldn't need to, right? Because it'll fail and make translate still.
Well, that's true. It would have failed before too long, but if you were going to have those 3,000 things
Right.
built, whatever that number is, it doesn't hurt.
Right.
It would be nice if GitHub would just do that itself, honestly, to change it.
I was thinking.
Status, but
Yeah.
what a website to create, GitHub. I mean, it's tempting, but you shouldn't fault them if one particular part of it doesn't work the way you want.
Yeah, and like the other thing that I think we take for granted is like it's a lot of CPU time to build all of CircuitPython.
Yeah.
And if we weren't an open source project, like we would have to pay for that, and that's not a trivial cost. I think at one point we ran the numbers. It's like $15 a build. It's like a day's worth of CPU time.
Yeah.
So like, thank you to Microsoft, who now owns GitHub, for basically paying the bill for all of the open source projects to use GitHub Actions.
Yeah, and when it's working well, it is a good advertisement for their services, and I think probably an effective one.
Yeah, I think like
this is Microsoft Azure, and you can see how well it's working or not working. So
right,
cool.
Right, and their business model is like they have companies that pay to use GitHub, but have private repositories, right? And so by having open source, that means everybody uses it. And then when you want to use it in your super secret startup that nobody should have access to stuff, you end up paying for it. Okay, we got a couple questions. Jeff, you can stick around. You can leave if you want. I assume we're kind of gonna do questions till the end here. Although I could talk about my audio stuff.
Making dinner here soon, so
yeah,
I'll stick around until we've asked or answered just these questions, and then I'll head off.
We'll do these last two, David and Mark. Let me be good and find my timecode window before I.
So to answer David, is the bit stuff only for the RP2040? It is only enabled for the RP2040 builds. There's nothing about it that isn't suitable on another build. So like if you have an idea about how to use this, we could potentially enable it in another port or for another board. But if we don't know how we're going to use it, we wouldn't necessarily turn it on.
Right. But yeah, it should be like, oh, it would be nice if it was on this port. We just flip the switch and it would be on. Okay. And Mark's question. Are you not going to answer this one, Jeff?
Oh, so Mark, I guess everybody can see it. I don't need to like read it or something.
I usually read it anyway.
Yeah. So Mark asks, would your other contributors merge their own work once approved? Or if, say, I do a review of Jeff's code and say, yep, this is fine, choose to merge it, or wait for one of the maintainers to do it. I mean, I think we are pretty much on we're adults here kind of footing. So we review because it improves the code, but once we've reviewed it, it's like any involved adult can go ahead and press that merge button. And if somebody thought it shouldn't happen, then you shouldn't have approved it, or you should have said, I've approved it, but we need to wait for other thing to happen first. Is something that happens sometimes. So like when we've had a release imminently coming out, I would get a review which says, this looks good, but I'm going to wait till after beta 3 to merge it. But yeah, in general, the review process is about checking for errors. And then after we've done that, I think it's up to whoever wants to, and with privileges, to go ahead and merge it. And I'll let you correct any of that or amplify the parts that you thought made the most sense, Scott.
No, I think you're right. I just want to be a bit more explicit. I think I think Mark. So background for folks, Mark has access for reviewing and merging, and is not at least paid a lot for Adafruit at the for stuff. I don't know if he's paid at all, but he should be at some point. But Mark's been great, and so he has access, and I think Mark's alluding to this idea that like folks paid by Adafruit have different privileges than those who are not, and that is definitely not my intention going forwards. I think anybody who we give write access to, and there's actually quite a list of folks that do have it. Like you should, yeah. So Mark is not paid by Adafruit. So anybody who has review access should feel free to merge and approve once things are reviewed. There is no special thing with us paid by Adafruit or not. And the reason I can say that is, one, you can always undo stuff, right? Like we have full history. We can always undo stuff if something was mistakenly done. But two, like we really want to move this project to be bigger than Adafruit. So like I don't want to treat anybody like it's a very fine line, and I definitely am like dancing around it of like paid versus unpaid and privileges and stuff like that. But like really the project I want to be more than Adafruit over time. I would love to have more companies besides Adafruit pay for folks to work on CircuitPython. And that happens a bit with folks who are like Unexpected Maker, for example, who sells boards and does do issue filing and bug fixing for that as well. So we're getting there. So I want to explicitly say like Adafruit funded folks should not have review privileges that are different. We do have administration stuff. But when it comes to reviewing, you're trusted for a reason. The one thing to be aware of is that like if there is a pending review, so if somebody chimed in and said, hey, what about this thing, and you think they might want to follow up, that's the point where I won't automatically merge in. If there was like a second person that was doing the review and may have follow-up further, I won't do it. But that should apply, again, that should apply to whomever did that portion of the review. For example, there was a review I did on a library today that Limor had reviewed. I actually disagreed with her on the review and approved the request, but I did not merge it because I wanted to give her time to say like, no, really, like we should change it. And so that's an example of where like, even though it was approved, I wouldn't merge it automatically. So yeah.
I guess I'll say one more thing, and this isn't exactly what Neradoc was talking about. They said, I've heard of that payment in exposure thing. I heard it's great. I've spent many years working on open source and free software not compensated. And, I did that, A, knowing that I was creating stuff to give away, B, educating myself, and C, I was giving away what I was making, but so many other people give away what they're making, and we enrich each other without money changing hands.
Right.
And now being in this world where I'm compensated for software that I get to give away, that's awesome too. And I think all of these different kinds of contribution and growth and building each other up are great, and I love it. And I'm so happy my life can be centered around it right now.
Right. Yeah, and it's like as somebody I was at Google previously, and like you spend so much time learning software that you immediately don't have access to the moment you leave. The idea that like I can work on CircuitPython and CircuitPython can be a part of what I do even if I stopped working for Adafruit is like incredible. And Mark does say, I just don't want to break the build. Well, that's not the problem. Like breaking the build is like if our CI tests pass, then you haven't broken the build. That's what they're there for. It's not your job to worry about that. It's the computer's job.
All right. Well, thanks for having me, Scott.
You're welcome.
And I'll let you wrap up your stream, and happy skiing tomorrow. I'm so happy for you that you live in a place where you can seek out snow because it's exciting and different. You're stuck with outside forever. until April.
Yeah, we did have snow on the ground this weekend, but it's
Oh
all.
yeah, in Seattle proper.
Oh yeah, we got like I think the official measurement was just over a foot.
Oh,
Um,
so that's like similar to that storm of was that 2 years ago?
I don't remember the last time we had that much snow.
Oh, I feel like I do because it was the year that I came out and met you in the spring because my wife was in the area for a training then when the snow
Ah,
came. And I think that would have been 2 years ago. But if you've forgotten it, I guess it was no big deal.
I mean, I would say that like typically about once a winter we have like a few days of snow
Mm.
in the lowlands. Right, like
Yeah.
it snowed on like what Friday or Saturday, and then it was gone 3 days later because it warm weather rolled in and rained. Um,
And for the day of the snow, she was staying up further north. I don't know how much difference an hour and a half north makes, but
it makes a huge difference because usually for us, we get snow where warm, wet air meets cold, dry air. Right,
mhm.
it's that convergent zone where you get the snow, and then depending on whether you end up with cold air or warm air, dictates how long you have snow on the ground. And so it's not necessarily that she was north, but it's like where that convergence zone ends up dictates where you get snow. And Seattle proper this time was like where it happened.
Nice,
So we got I guesstimated like 8 inches, but yeah,
nice.
it's nearly all gone. I can see a little pile out my window. That's it. But
And yes, Bruce, it's Jeff. Good to see you.
awesome. Yeah, thanks again, Jeff, and we'll check in with you again when you have some more stuff you want to show off on the stream.
All right, sounds good.
Have a good weekend. Awesome. Well, again to Jeff for joining. Um, we've got about 20 minutes left, so maybe what I'll do in the 20 minutes is just go over what I've been working on. And where I left off last week. So last week I left off with I was working on I2S and it was having the problem that it was hanging. And so what I did is I found that the reason it was hanging, or I'll take another time code. Ooh, the time is like not too far off. So the reason it was hanging is that it was actually tearing everything down. It was reusing the same PIO state machine for the NeoPixel again, but the problem was that the DMA was still set up. The DMA was still set up to send the I squared S bytes to the state machine, which meant we were basically transmitting audio bytes to the NeoPixel, and the NeoPixel code waits for it to finish and stall, and it wasn't stalling because the DMA was continually writing to it, so it was a problem. So what I did is I added more code to tear down the DMA, and that fixed the stall issue. So in particular, since we've been talking about PIO, I actually particularly want to talk about the improvements that I've added this last week to the PIO for CircuitPython. So if you want to follow along with what I'm working on, you can go to github.com/tannewt/circuitpython. And there's a lot of branches. I wish that GitHub was better about this, about telling you like the most recently updated branch. I should probably actually. What does view all branches do? Here we go. This is exactly what I was just saying. I wish they did. So you can see my default branch, and it shouldn't be because I don't ever update the master branch. In fact, we call it main now. But you can see active branches here. And so audio PWMIO is what is merged in now. And then there's also this audio bus IO, which is where I've been working. And So this is where the changes are, and you can do this compare. It usually fails because by default, because I forked MicroPython originally, it actually compares me to MicroPython, which is a pain. Yeah, sorting on the dropdown would be nice. Bruce S asks, has anybody done CAN bus yet for the PIO? Not that I know of. I assume that it's doable though. But in CircuitPython, that would be CAN IO. It looks like it actually passed. So there's 5,000 plus commits different and 4,000 changed. But we actually want to switch this to Adafruit CircuitPython, and then this is usually unhappy. Did that work? Yes, it did. Oh, I overrode. That's silly. Change the branch, but not the thing. Okay, so here's the comparison versus... Bruce says, I usually do get branch -r -- sort equals minus committer date. That will work for local branches. That's a good tip, actually. I've looked at reflog to know where I've been working recently. Okay, so this is all work in progress code. I will rebase this. So here you can see I'm actually doing resets. And anytime you see, I do a lot of printf debugging, and I'm still in the middle of it. So you can see that I have a printf here and more DMA teardown stuff. Let's look. This is the interesting bit, I think, which is the changes I've made to RP2 PIO state machine. And mainly I'm adding initial pin state and initial pin direction. So there's 3 ways that you can do outputs from a PIO, and they can all also do direction setting. And so as it is checked in right now, we don't mess with it, and you have to run instructions on PIO to set it up to what you want. But most people, when they first get started with PIO in particular, they expect you to do outputs immediately. So what I'm adding here is I'm basically setting the initial state to, Bahamut asks, this is for the Raspberry Pi Pico. Yes, it is. It's for the chip on the Raspberry Pi Pico, which is the RP2040. I also have a prototype Feather on my desk that I actually use more than the Pico, largely because it has a reset button. But those should be coming out not too long, because there was that we're like kind of all designed it already, and we saw pictures of chips that are bound towards Adafruit. So we should start to get the first batch of Adafruit specific RP2040 stuff built once we have the chips in hand. And the Raspberry Pi people have chips, and they've said that they're coming our way. So hopefully it's not too long until that happens. Okay, so here's what I've got for out. Oh, this is not right. I never updated it here. It should be, these 2 should be out, these 2 should be set, and these 2 should be side set. Since I'm going over this, let me just pull it up. Let me just fix it in case I haven't already, because I'm basically reviewing my own code. So we're in state machine in bindings, and we found that this might be easier to read as well. Yeah, these are wrong. So it's a lot of stuff. So here's the out pin settings, and then these are set pins. So this needs to be set, and this needs to be set, and then these 2 need to be set, side set. So the challenge with these is that you kind of have like 2 states. You have the value that they're outputting and whether they're actually outputting it. So for each of those, we have a pair of initial states. We have initial state and we have initial direction. So by default, the values will be low. And did I change it to value? No, I called it state. State might be a bad name for it. And then direction is all 1s, which is output by default. And the reason it's 1F for set and side set is that you can only have up to 5. So 5 bits is 1F. Yeah. Mark says Evan's tweet was very exciting. I wonder how many total microcontroller chips are being sent to each vendor. Well, I think that the tweet said it was like, what, 1,200 per? Something like that. We'll see. I fully suspect that they're going to make a ton of them. This is going to be very popular. And at some point, like, it will catch up to what people want. David G says, so you will get a few chips. The Limor will do a limited run. Then she will send an email during the stream to say they're available from the shop, and you will leak that. Potentially, we'll see what the timing is on that. But yeah, well, like, she literally got 10 to start with. Like, my feather I'm running is like literally from that 10. Mark says, oh, good. Hopefully that will be enough. Super excited for the Adafruit feathers based on this chip. Yeah, watch the Discord. There can be a delay between when the product goes live and when the email goes out. Because secretly when I need a board, like I will need to get a new RP2040 feather because the version I have is older than the production one. So like she'll ping me before she'll ping the people who are on the email list. So occasionally that happens in the public Discord. So if you're really keen on getting that first batch, make sure you're on the Discord server. And what Dave is also referring to is that literally, like, I've gotten those pings during the stream. So that could happen as well. The other thing is JP's stream. Sometimes what they'll do is JP will stream and then they'll do the email after that as well. Neradoc says, what, not even putting a heat gun to a pico? That's too easy. Yeah, you could do that. I don't think she's had to yet, but that's one thing you could do if you're developing your own board, is you usually have a heat gun that could actually remove the chip from a pico. And for $4 on a pico, like, that's not a bad proposition. So Bahamut in the Twitch chat is saying, I ran into an issue with the ESP32 MicroPython and tried it in C, but still had timing issues at 1 megahertz clock. I would drop in the Discord to ask folks for tips on making that. Okay, another question. Since I'm questioning timecode. It's good. I like questions, even if I can't answer them. So Ian says on YouTube, has anyone asked why did Pi develop their own chip? So I don't work for Raspberry Pi. I found out about it a bit earlier than normal, but I don't have a ton of insight. I would recommend listening to the amp hour that the Raspberry Pi folks were interviewed on. I think it's just the amphour.com. Yeah, if you go here, you'll see there's this recording they did with the Raspberry Pi team. I think they cover it. I listened to it. They always, I think, thought that they were going to do that. And, they had ideas about what they could do if they could develop it themselves. Like, they have the background in designing chips because Raspberry Pi was founded by people who designed chips for Broadcom. So, like, they have the skill set to start. So I think that's part of it. And then when you have the skill set to make something, like, you see the flaws in the other designs. And particularly, I think the thing that caught my eye with this is, like, the PIO is really cool and the documentation is excellent, but also, like, they clearly focused on the ability to get data through the memory bus and stuff. Like, a lot of people, when they talk about microcontrollers, are talking about the core and the clock speed, but that's like just one component that dictates how fast things can happen. And seeing the RP2040 datasheet and how they thought about memory accesses and like being able to stripe data across the bus and the DMA that they have, like they were thinking outside the core as well, which is pretty interesting. Mark says, just wanted to say that I've been watching the recordings after the fact as I'm usually at work. Thank you for going over debugging on the last live stream. It was super helpful. Awesome. Glad it was. I think like that's what these deep dives are all about, is to like show all the different things that I do, because I'm not a good documenter in the sense of like writing it out. But I can record me doing it and talk about it verbally as I do it. Okay. Back to, yeah, so something I did just yesterday was this initial state, which should make it much easier to get started with PIO. I added this wait for TX stall flag, which impacts how write works. So basically, as you're writing data out, it goes from memory to a FIFO via DMA usually, but it can also use the CPU to do it. And then once it's in the FIFO, which is a first in, first out thing, and it's either 4 entries long or 8 entries long, depending on how you have it configured. And then those values get shifted into the state machine's output shift register, OSR, and then, you know, depending on how many bits and how you're transmitting them, like it may take some time to get all the bits out of the OSR. So what txstall does is it ensures that when you write data, it ensures that the data you've written is not only in the FIFO, but also like out of the OSR as well. And the reason I added the stall in the first place was with neopixel, but because in the neopixel code, I initialize the state machine, I write the bytes, and then I shut it down. And I was actually shutting it down too early. I was shutting it down before all the bits were shifted out. And so I made write just like finish once that happens. But with I2S, where I'm never stalling, I2S is like pulling values, but if there's no value, it uses the last one. So it doesn't wait, it doesn't stall at all. And so if you use that, then your write call will never return because you'll never stall. So that's why this is here. This is the longer form description of all that. This is the boilerplate to add it. So I'm adding more functions as well. I'm adding a restart, which allows you to just reset the state machine. It reruns any initialization you did, and it re-enables the clock. And you can see a to-do here for me. There's actually cases where you would want multiple state machines to restart at the exact same time. And so in the future, what will likely enable is like restart one, and then you could pass in more state machines that you want to restart at the same time. So it would manage that. This is what I alluded to earlier, which is run. So this allows you to run instructions on the state machine. That means that you don't load them into memory, you just run them directly. And that same code is used for the initialization sequence as well. Like I said earlier, I was talking with Luke about this, and you can have it the clock disabled, but still write stuff to the instruction register, and they all still, like, it all works still. The only thing that doesn't work is delay, because you're kind of like manually timing it at that point. Stop does the opposite, which is it just stops it from running altogether. And I use this for I2S, where you can actually stop the I2S, and it won't output any clocks or anything. Oh, and in this change, I also have it where you can, you'll now be able to have, so as it is checked in right now, you only write byte arrays, and it only copies eight bits a byte into the FIFO at a time. But again, with I2S, we potentially want to write either 16 bits or 32 bits all at once. And so I added the ability to pass in Python land, it's arrays with a particular type code. And then this is the under the hood stuff that figures out like how many bytes long within a regular byte array it actually takes at a time. So you'll see that just to the right here, there's this stride in bytes. So stride is the idea of like how many bytes per kind of unit you're talking about. That's what stride is usually referring to. So added that to write, which is what we had already. I also am uncommenting read into. So this will allow you to read data back, which I'm actually trying to implement PDM, pulse density modulation, which is a common way to read a microphone, which is what I actually have here. And I need to debug, but we're almost out of time, so I won't do that on the stream today. So read into will be great. That's getting data from the PIO into Python. And it does all of the stride stuff as well. And it doesn't work because I'm trying to use it in PDM, but it's not working. So there's some debugging there to do. Write read into is, these three functions are modeled after SPI, where you can write, you can read, and you can read at the same time as writing. But this one's a little bit different. Like I literally copied a lot of this from there. But the state machines are different in that SPI, you have one shared clock and like the data goes in at the same rate it comes out. But with a state machine, you don't have that constraint. So basically this will wait until both everything's transmitted and everything has been pulled in before it returns. And we'll see, like I haven't actually used this yet. We'll see how people like that. I added the ability to set the frequency. So this will allow you to change the frequency of the state machine from initialization. This is important for I2S because the rate that we transmit data depends on the data rate of the sample that we're playing. So we needed the ability to set the frequency. So I plumbed it through here as well. And here you can see I'm uncommenting and adding those things in. That looks good. Here's just adding more there. Adding the common hell stuff. But yeah, so I have I2S and I think it's working. It's not perfect. The buffers are a little bit small, so if you get a hiccup, it can like cause your audio to hiccup a bit. So there's some tuning to do, but it does work for what I can tell. So I2S is working in this. And I know some folks who watch the stream have pulled my branches before, so give it a shot. The other thing, so I2S is part of this audio bus IO module, and the other counterpart to it is PDM in, which is like a more basic form of audio, digital audio, where it's just like the percentage of or like the fraction of ones dictates the value. And there's some digital signal processing that I don't really understand, and we'll see that in just a second. But I cribbed this from the SAMD21. And so the PIO, I think that should work, is very straightforward. You do in bit pin 0, in from pins of 1, so just shift 1 bit in. And then the side set here is clock. And that should just shift in a bunch of 1s and 0s. MD Roberts says, what codecs will you support on I2S? So there's 2 versions of I2S, and I think I have both working from what I can tell. Like, it's just, the version of I2S that I know is just like the sample values, right? Like, and there's like classic I2S where the last bit happens after the frame is changed, and then there's left justified where it doesn't. And both of those should work, although I've only tested the regular I2S version. But I don't know. Codex seems to imply that there's more than just that over I2S. But those are the ones that I know of. It's just like raw sample stuff, which might be PCM. Okay, so this is for PDM in. Yeah, and Alvaro says, so that's for PDM mics. Would it work with this one? Oh, you mean No, because that's an I2S MEMS microphone. It shouldn't be hard to support. We just haven't had a need to support it yet. It works with this one that I have here, not this. Let me unplug. Here's what I've got set up. So this is my current testing setup. There's the PDM mic there. It's the same one that we have on both Circuit Playgrounds, I think. I think it's both on there. The I2S would be easier, but like PDM we already have. So that's why I'm supporting it. Yeah, so that's setting up the program, and it basically just needs to. So here's a sync filter. This is the thing that converts like a bunch of 1-bit samples to like proper 16-bit samples. That's what this does. I don't really understand how it works. It's something Limor did for this AMD21. I like totally got lost in those weeds and couldn't find my way out. So she rescued me. This is all untested code. I have a PIO version, like I alluded to. Yeah, so here's my testing version. So this is just using, you can see I'm just using the RP2 PIO directly. And then I was just trying to like do a read into and print out the values, but it's hanging for some reason. So this is exactly the example code that I will put in the PIO ASM library as example code. Summersoft says, yeah, sync filters. I don't miss researching that when I briefly worked on the NRF52 PDM, and DSP is such a strange land. Yeah. Yeah, we'd love to find somebody who understands it to help us out with that. It's just we haven't been able to. Yeah, so that's basically it. There's this record to file, which the thing I copied from didn't implement either, so I'm not sure if we implemented it at all. But then this is just the boilerplate of like what's in the struct for the object. So that stuff's coming. You can see these are just debug. This is just debug stuff. And I'm just trying to figure out exactly. I'm trying to get it all kind of working before I check it in, which hopefully tomorrow I'm hoping. So I'm going skiing, but we're gonna try to get out of there kind of early, and so we're gonna work later in the day. So the hope is that I'll have some time and be able to get the PR out then. So that's it. I think if there are any final questions, ask them away. But I'm kind of hungry. I need a snack, and I didn't grab my other water. But I should say I got my Hacktoberfest T-shirt finally. It's not October anymore, but it took them a little bit. I wasn't one of the kind people. I didn't get the tree planted for me. I got the T-shirt. All right. Well, I don't immediately see. I know Bahamut asked, so is there a good JTAG debugger for the ESP32? So I think both Jeff and Lucian in Discord have gotten the ESP32 S2 working with JTAG, so I would ask on Discord. I got it working just so much that I could connect to it. I didn't know how to use it at all. I think I'm gonna actually need to get the J-Link going for this bug I'm hitting, because it's freezing to the point where the like USB disconnects. So I've got to figure out why that is. Mark says Mark Tomlin says the only DSP I've done is from the software-defined radio world. Reading and trying to understand I over Q data is very hard. Awesome. Well, let's wrap up. Let me take one final time code here before I go have a snack. So thanks again for everybody for joining me. Special thank you to Jeff for joining me for this deep dive. Hope you all enjoyed it. As always, I do this deep dive usually on Fridays, but occasionally on Thursdays if Friday's going to be busy for some reason. Tomorrow I'm going skiing, so that's why we're doing it on Thursday here. 2 p.m. Pacific. I'm based in Seattle, so that's why it's on Pacific time. Usually Fridays. Check the Adafruit blog on Wednesday to see if I have posted there. I do try to stay ahead of time, but I totally messed that up last week because we were supposed to ski on Monday, but we decided to go on Friday instead. Anyway, usually happens once a week. Occasionally we have guests. And if you want to hang out with me and a lot of other folks and ask more questions, please join the Adafruit Discord server, adafru.it/Discord to check that out. And Bruce S says they'll be skiing where they are as well. Anyway, thank you to all our CircuitPython contributors. We really appreciate it. It's a great project. Hopefully everybody enjoys working on it. And as always, if you want to get started contributing, also feel free to reach out to me or anybody else on the Discord server. And with that, I'll pet the cat. Thank you all, and we'll see you next week. Spook, spook, spook. Giving yourself a bath. Scratch, chin, scratch. All right, have a good weekend, everyone.